let's look at this problem. 2024 AMC 10A. Problem 18. There are exactly k positive integers b with 5 less than or equal to b less than or equal to 2024 such that the base b integer 2024 is divisible by 16, where 16 is in base 10. What is the sum of the digits of k? So we want to dissect this integer, which is basically 2024 in base b. That's 2 times b to the power of 3 times plus 0 times b squared plus 2b plus 4. So this thing is in base 10. And we know that this here is divisible by 16. That means that b cubed plus b plus 2, which is if we divide the expression by 2, is divisible by 8. So casework then, which is like the most straightforward way. There are obviously faster ways that maybe you can do in 30 seconds, but this is the most straightforward way that doesn't require excessive thinking. So firstly, casework, as in there's only 8 cases as in b's divisibility, so we can just test each of them out. Because this expression here, if whether or not this expression is divisible by 8 is dependent to b, whether or not b is divisible by 8 and b's remainder when it is divided by 8, because the only variable here is b. 2 is a constant, so b matters, right? So let's say b was divisible by 8. Then what does this mean? If b is divisible by 8, then b cubed plus b is divisible by 8, because it's just like some 8s plus more 8s, so that's divisible by 8. However, plus 2, when this expression plus adds 2, this whole expression here has a remainder of 2 when it is divided by 8. But we know that in this case that this expression b cubed plus b plus 2 is divisible by 8, so it should not have any remainder, so this case does not work. And similarly, when b has a remainder of 1 when divided by 8, then this expression would have, so this is like modular arithmetic stuff. You can watch videos on this, but basically you can directly plug 1 into b. So 1 cubed plus 1 plus 2 would be 4. So this expression has a remainder of 4 when divided by 8, which again does not work because the remainder should be 0 in this problem, not any other number. So we're trying to find cases where the remainder when b cubed plus b plus 2 divided by 8 would be 0. Now when b is congruent to 2 mod 8, which is literally the same thing as saying b is divisible by, when b is divided by 8, the remainder is 2. We have b cubed plus b plus 2 is congruent to, plug 2 in to the expression. 2 cubed is 8 plus 2 would be 8 plus 4, which is 12. So when b divided by, so this expression b cubed plus b plus 2 divided by 8 has the same remainder as when 12 is divided by 8. And 12 divided by 8 has a remainder of 4, which is obviously not 0, so that does not work. Now let's look at more cases. When b is congruent to 3 mod 8, b cubed plus b plus 2 is congruent to 27 plus 5, 32, which in this case is actually divisible by 8. So this case works. Okay, so what do we do when a case works? Well, when a case works, this means that any b that is congruent to 3 modular 8, which looks like any b divided by 8 with a remainder of 3, works from 5 to 2024. So we want to find all these numbers from 5 to 2024 that have a remainder of 3 when divided by 8. So what numbers are there? 11, 19, 27, etc. Up to what? Well, 2024 is divided by 8, so the last number would be 2019. How many numbers are here? We have 2019 minus 11, 2019 minus 11 divided by 8 plus 1 equals 2019. So 2008 divided by 8 plus 1. Anyways, that gives us 252. And then we have when b is congruent to 4 mod 8. Again, we plug this into this expression and we get 64 plus 670, which when divided by 8 gives us a remainder of 6. So that does not work at all. Now, this should be a cross. Moving on, when b has a remainder of 5 when divided by 8, b cubed plus b plus 2 is congruent to 125 plus 7, 132, which is, again, just not divisible by 8. Like, this is not 0, because this is congruent to 132 divided by 8, mod 8, and that's just not 0. Okay, last two cases here. When b is congruent to 6 mod 8. Now, what is this here? Well, there are two ways we can do this. One, just directly plug 6 in, which is avoiding, really straightforward if you don't know anything about modular arithmetic. Another way is b is also congruent to -2 mod 8, because 6 minus 8 is -2. So that's one of the rules. So -2, you can plug -2 in then. -2 to the power of 3 is -8. So this is -8, which is congruent to 0 mod 8, which works. So how many numbers have a remainder of 6 when divided by 8 from 5 to 2024? Well, we have 6, 14, all the way to 2022. How many numbers are there? 2022 minus 6 divided by 8 plus 1. That is 253 numbers. Last case here. This either works or doesn't work, but this is the last case. Again, we can directly plug 7 in, or rewrite this as b is congruent to -1 mod 8, because 7 minus 8 is -1. So this means that this expression is -1 to the power of 3 minus 1 plus 2. So that's just 0, which obviously works, because we want the remainder when this expression is divided by 8 to be 0. How many numbers are there then, with a remainder of 7 when divided by 8? We have 7, 15, all the way to 2023. Now, this series of numbers is just this series of numbers. It's just this series of numbers plus 1. So there are, again, also 253 numbers. So 252, so k would be the amount of numbers. 252 plus 253 plus 253, which is 758. Now we want the answer to be all the digits of k. That's 7 plus 5 plus 8, which would be 20. Now, just don't get this step wrong, because last time I did this, I got 21 here, which obviously is not correct. So the answer is D.